morning, students. Welcome to the functions in programming for problem solving using C language. So first topic is designing structured programs. Designing a structured programs. Right? So the structured programming approach to program design was based on the following method. To solve a large problem, that problem will be decomposed into subproblems. Right? So to solve a large problem, break that problem into several pieces and work on each piece separately. Right? So to solve each piece, treat it as a new problem that can be broken down into smaller problems. Right? First, we can break the large problem into different subproblems. Again, the subproblems are again divided into sub-subproblems like that. So repeat the process with each new piece until each can be solved directly without further decomposition. So we have to break the subproblems until without further decomposition. So in top-down design, a program is divided into main module and its related modules. So each module is in turn divided into submodules until the resulting modules are intrinsic. That is, until they are implicitly understood without further division. Right, we'll see. So here there is a main module. Right, the main module is broken down into three modules: module 1, module 2, and module 3. Again, the module 1 is decomposed into three modules: module 1A, module 1B, and module 1C. Now, the module 2 is broken down to module 2A. Module 3 is decomposed into module 3A and module 3B. Right? So this is subprogramming. So this is the design of the subprogram structure in C language. So first we are taking a large problem. That large problem is divided into subproblems. Here we have a main module. That main module is decomposed into several modules. Here there are three modules. Again, that module 1 is decomposed, module 2 is decomposed, and module 3 are decomposed. Right? So this is. So here, a communication between modules in a structured chart is allowed only through a calling module. See here in this diagram, so this is the calling module and these three are the called modules. So this is calling module. These three are the called modules. Right? So for this calling module, these three are the called modules. Again, so this is the calling module which calls these three. Now this is the calling module and these three are the called modules. Right? So this is the calling module and this is called module. This is the calling module and these two are the called modules. For example, module 1A wants to communicate with module 2. Module 1A wants to communicate with the module 2. Right? So this is the called module. So the communication can be done through only the calling module, via calling module. So the calling module of module 1A is module 1. Right? Then the calling module of module 1 is main module. Right? So then that means module 1A transfer the information to the module 1. Module 1 transfer the information to the main module. Right? So now the module 2 receive the information from main module. So module 2 receives the information from its calling module. So its calling module is main module. Right? So for that, module 1A transfer the information to the module 1. From module 1, it goes to the main module. From that, module 2 will be received. Suppose module 1 wants to communicate with the module 3. First, the module 1 transfer that information to the calling module. This calling module is main module. So from the main module, the module 3 receives the information like that. Like that, the communication will happen between the modules. If module 1 needs to send data to the module 2, the data must pass it through the calling module, that is main module, that already discussed. So no communication can take place directly between the modules that do not have a calling call relationship. That means, see, here module 1 and module 2 cannot be directly communicated, right? If module 1 wants to communicate with module 2, so it is possible only with its calling module, that is through main module only. So these two cannot be communicated directly. So the technique used to pass data to a function is known as parameter passing. So through this technique, we will pass the information from called to calling, called module to the calling. Now we are going to discuss about a function. So what is function? So function is a group of statements. Function is nothing but a group of statements that together perform a task. Function is a group of statements that together perform a task. Every C program has at least one function which is main. So every C program has at least one function, what we call it as main function. So always the execution of a program starts at main only, but it can call other functions to do special tasks. Right? So why functions? What is the need for using a functions? When we write a large program, it becomes difficult to keep track of the source code. The job of the function is to divide the large program to many separate modules based on their functionality. So that is first one. So whenever we are writing a large or complex problem, it is very difficult to keep track of the source code whenever the error is encountered, or it is very difficult to understand the code, or whenever you have to keep track the code, it is very difficult to understand the program as well as the errors also. For that reason, we are decomposing that problem into separate modules. Right? So second one, reusability. For example, if you want to find a factorial of a given number in our program 10 times, you need to write the factorial code 10 times. Instead of writing the same code 10 times, we are writing only one time with the help of function. With the help of function, we are writing only once. We are writing that code only once. That code can be reused by calling it 10 times. So that is reusability. Reuse the same code several times. And third one is readability. So with the help of functions, readability is more. Right? So instead of writing the entire code, just you are calling that. Whenever you are calling that, so immediately that function will be executed. Readability is more. Reusability. Right? It saves the memory space. It reduces the code size. Right? So instead of rewriting the same code, we are writing only once. That will be used several times. So memory size is also, memory space is saved. Coming to the advantages, the function provides modularity, right? Functions are used to avoid rewriting the same code or same logic again and again. We can call a function any number of times. Once you are writing, just you are calling any number of times. That is another advantage. A large C program can easily debug when it is divided into functions, right? When it is divided into functions, debugging is easier, right? So identifying and rectifying the errors is very easy. So when you are writing a function, separate function independently can be developed according to the needs, right? So these are the advantages. Next, C language supports two types of functions. One is a library function, another one is user-defined function. So what is library function, right? So library functions are a predefined set of functions. Their task is limited. Library functions are not required to be written by us. A user cannot understand the internal working of these functions. So there is a difference between library book and notebook. So in the library we are having a textbooks. So we can just use the textbooks. We can just use the library books. We are not editing those books. They are already written. So that means library function nothing but the functions which are available in the library, just we can use them. We are not editing them. We are not writing the code for them. Right? Coming to the user-defined functions, just like a notebook. In a notebook, you can write and read. In the similar way, so user-defined functions must be created by us. So whereas library functions are created by the designer. So a user cannot understand the internal working of those functions. So for the library functions, you need not, there is no need to understand the internal working. So that code is already written, that function is already written. We can just use that code and perform the operations. That is about library functions. So the user can only use those functions but cannot change or modify them. For example, square root of 81. So square root is the library function. Square root is the sqrt, is the library function. Right? There is no need to write the code for that. Just you can use that function. That is a library function. So with the help of that, you can perform the operation. Square root of 81, that gives you a result 9. So here the user need not worry about its source code, but the result shown should be provided by the function. In the similar way, printf, scanf, square root, cos, string card, all these are the library functions. Right? So these library functions are available in the header files. Right? For example, printf, scanf, they are available in the header file stdio.h. Whenever we are using these two functions, you need to include stdio.h header file. So in this library, these functions are available. They are predefined. So whenever you are using printf and scanf functions, so just it will verify the syntax of printf and scanf in stdio.h. Coming to these, square root and cos, they are in math.h, math header file, right? So whenever you are using these library functions, you need to include this header file. In this header file, these two functions are defined, predefined. So string cat, so string.h, header file is string.h in this library, so that function is available. So these are the library functions. You need not write the code, just you can use those functions, Coming to user-defined functions, the user-defined function has to be developed by the user. So in case of library function, they are developed by the designer. So user-defined functions are developed by the user. So the functions defined by the user according to their requirements are called as user-defined functions. Right? The user can modify the function according to the requirement. User can modify the function according to the requirement. The user certainly understands the internal working of the function. User certainly understands the internal working of the function because user only can write the code. That is why he can understand the internal working of the function. Whereas in case of library function, there is no need to understand the internal working of the function just we can use. So coming to the user defined function, main is the user defined function. So the main function is defined by us, user only. Add, sub, null, div, all these are the user defined functions. So with the help of this we can write some code and use it. So that is about user defined functions. So in this we are discussing about user defined function. Function means here we are using user defined functions, right? We are writing the functions. So the function which is developed by the user is called the user defined function. A function name is used 3 times. So whatever the program you written, so the function name is used 3 times. So at the time of declaration, at the time of call, and the definition. So a function is for declaration, is a call, and for definition. First one, function declaration. Second one, function call. Third one, function definition. So function declaration also known as function prototype. It is also known as function prototype. Function call is also nothing but calling function. We'll discuss one by one later. Third one, function definition. It is also known as called function. Thus, function declaration or function prototype. Function call or calling function. Function definition or called function. Right. First one, function definition. See here, functions are shown in 3 parts. First part is function definition. When a function is defined, space is allocated for that function in the memory. Right? So, when a function is defined, so immediately the space is allocated by the compiler, right, for that function in the memory. Right? A function definition composes 2 parts. One is function header, second one function body. So function definition comprises the 2 parts. One is function header, second one function body. Coming to the syntax. So syntax for the function definition, right? So first it is having a function header. So this is a function header. This is function header. So here the function header is a return type, space, function name, parenthesis. Inside the parenthesis we are giving the arguments. So type, data type, variable name 1, data type, variable name 2, and so on. N number of arguments we can give. So for each variable you need to give its data type. Then open brace, close brace. Between that you can write the body of the function body of the function. So the last statement is return statement. If the return type is some type, right, then return statement can be used. If the function does not return anything, you can use void. If the function returns something, then you can use return type as some data type. So the data type can be specified based on the type of the value the function returns. So this is the syntax. So second one, body of the function. So this is function definition. Now, second one, function declaration or prototype. Right? In C, all functions must be declared before they are used. All functions must be declared before they are used in the program. So this is normally accomplished by using a function prototype. The function prototype tells the compiler about the function name, type of the arguments to be passed, and return type. So the function prototype tells the compiler that, okay, so the type function name is this, and the type of the arguments used, and return type. All these are told to the compiler. The function prototype tells the compiler. The compiler will also catch differences between the number of arguments used to call a function and the number of parameters in the function definition. right? And also it will match. So the compiler will also catch the differences between number of arguments used to call the function and the number of parameters in the function definition. So with the help of prototype, we need to check the calling function and called function, right? The number of arguments passed in the calling function must be same as the number of arguments in the called function, and also type of arguments passed in the calling function must be matched with the type of the arguments used in the called function. That is to be verified with the help of function prototype only. So who will verify that? Compiler will verify. Compiler catch the differences. Now this is the syntax for function declaration. So return type, function name. So inside the parenthesis, type parameter name 1, type parameter name 2, and so on. N parameters followed by semicolon. So this is function declaration syntax. So here the use of parameter names is optional, right? Just you can use a type, comma, another parameter type, another parameter type, like that. Only you can use a type or you can use the names also. Here the parameter names are optional in case of function declaration. And third one is function call statement. The function call statement invokes the function. It invokes the function, which means the program control passes to the function. Whenever the function call statement is encountered, immediately the control passes to the function definition, and then the function definition will be executed. Once the function completes its task, the program control is passed back to the calling environment. So whenever the calling statement is invoked, immediately the program control transferred to the called function. Now the called function will be executed. After executing the called function, again the control passed back to the calling environment. So this is the syntax for function call or calling function. Function name of argument list. Function name of argument list. Right, now I explain this with the help of the program. See here, first one. So first I am including the header file stdio.h. Then function declaration. So here it is my function declaration. So the function name is max. So max is the function name. Here there are two arguments of type integer, int x comma int y, or just simply you can use int comma int in the function declaration, int comma int or int x comma int y. And the return type is integer. That means this function return integer value. This function returns integer value. Maximum of two integers are found, then it will return the integer value, either x value or y value can be returned. So this is function declaration. Next I am writing a main, void main, or you can use int main, right? So here it is optional. You are not using anything means it is void. Arguments, no argument means you can use void, or directly you can use parenthesis. Here you can use void or int main. So int a is equal to 10, b equal to 20. First I am initializing two integer values. A value is 10, b value 20. Right? Next, function call m equal to max of a comma b. M equal to max of a comma b. This is the function call or calling statement. Next, maximum value is %d. So print m value. So here it is the function declaration and it is the function call. Right? Next, function definition. Function definition. Int max of int x comma int y. First it will check if x greater than y, return x, else return y. Okay. See here, first it is the function prototype. So its function name is max. It is having two arguments. So during the function call, the compiler will check so this function with the function definition header. See here, function name is max. So here also function name is max. So it will compare both. So here there are two arguments. Here also two arguments are there. Here both are of type A, B of type integer. Here both are of type integer, right? There is a match. So these two are compared with the help of this one only. So this function returns integer value and this function returns integer value. Yes. See, for example, first. So execution begins at the main. So A value is 10. A value 10. B value 20. Right? So just it calls max of A comma B. Right? Max of A comma B. Here X value is 10, Y value 20. That means X receives A value, Y receives B value. See here I am writing A value 10. Sorry. A value 10, B value, right? X. So X receives A value, that is 10. Y receives B value, that is 20. Here. X receives A value, Y receives B value. Now we compare. If X greater than Y, 10 greater than 20, false, then else will be executed. Return Y. What is Y value? 20 will be returned. 20 will be returned. So maximum of AB value is 20. Control back to this calling environment. Max of AB value is 20. That 20 is assigned to the M. That 20 is assigned to M. What is M value now? It is 20. Now it will print the maximum value is M. 20. Maximum value is 20. That is how. That is the. Next. Another program. Multiply the two numbers. Program to multiply two numbers. Here this is the function declaration. Function declaration. So function name is multiply. Right? It takes two integer arguments. I am going to multiply two integers. That is why two integer arguments, and also it returns integer value. So return type is integer. So that is the function declaration. Next, inside the main, so I am taking product variable, product equal to multiply of 6 comma 7. Directly I am giving actual values. So 6 and 7. Now this is the function definition. Return type is integer. Function name is multiply of int x comma into y. Int x comma into y. Right? So execution starts here. So multiply of 6 comma 7. This is the function call. So whenever the function call is encountered, the control is transferred to the called function. Control is transferred to the called function. That means x receives 6, y receives 7. X value is 6, y value is 7. Right? So now execute this function. Now this function will be executed. So x value is 6 and y value is 7. 6 into 7 is 42. Return. So now the return statement will be executed. Return x into y. So that 42, it is computed. 6 into 7, its value is 42. It is returned back. 42. The return statement is executed. Its value is returned to the calling function. Multiply of 6 comma 7 value is 42. So 6 and 7 is computed, right? So it is 6, x receives this, y receives 7, right? So this through return statement, the value will be returned. So multiply of 6 comma 7 value is 42. That is assigned to the product. That is assigned to the product. If you print, if you want to display the product, just you can use printf statement. So like this, the values can be passed. The compiler will check number of arguments in both calling function and called function, and also the type of the arguments it will check, and also the return type also it will check. right? So this is about user defined functions, right? So what we have discussed in this class, so designing structured programming, designing structured programming. So in that what we are doing is, so main module is divided into sub-modules. Again the sub-modules are further divided until there is no decomposition, right? So the communication is to be needed between the modules. So the communication is to be possible only through the main module or calling module. So that is second one, functions. So function is nothing but group of statements used to perform a specified task. So there are two types of functions we have: library functions and user defined functions. Library functions, user defined functions. So library functions are the functions which are all predefined. User defined functions are defined by the user. So in case of library function, just we can use the function to perform operation. There is no need to understand the code. There is no need to write the code, or there is no need to change or modify. We are not able to modify or change the code. In case of user defined functions, we only develop the code. We have to understand the code, right? So that is user defined. So in functions, we have discussed about the user defined functions only. So user defined functions can appear in the program in three parts. One is function declaration. First part is function declaration or function prototype. And second one is function call or calling function. And the third one is function definition or called function. Function definition or called function. We'll continue in the next class.